The manager's risk attitude also has impact on their decisions. The manager, him or herself, can be risk averse, means that you'll prefer a project with a lower expected value if the risk is lower than the project with a higher expected value. Risk loving is you prefer a project with higher expected value and higher risk to one with lower expected value and lower risk. Risk neutral means that you're maximizing expected profits and the variance doesn't impact the risk neutral manager's decisions. Here's a problem illustrating the differences in selection of projects. Here we have 4 possible projects and 2 different economic conditions, boom and recession. We have the mean of what is expected from that project and a standard deviation of what might occur given the possible outcomes for the 4 projects. When we solve this problem, we see that 2 we discard immediately. The easiest one to discard is the T-bill because it returns lower than any of the other items, and yet we feel that we've captured 100% of the probabilities. Therefore, there's no chance that the safe T-bill is better. The other that you see in red is the baloney project, where the mean is a negative. So in a boom time, it's a negative, recession, it's a positive, but not sufficient to overcome the 90% boom with a negative outcome. So we wouldn't choose that project, which leaves the other 2, caviar and joint. In the first case, we have a higher mean of 17,200, however, a higher standard deviation of 8,400. The next project, joint, has a positive mean, 9,400, and quite a bit lower standard deviation. So these would be the reasonable choices of a manager, given the relationship between risk return and absolute amount of the return itself. Notice something else from the prior example, that there is a chance of having a high return from choosing the riskier one, or a lower but still positive expected return for the second one. You could actually reduce the risk by investing in multiple projects, and that's called diversification. Whether it's optimal to diversify depends on the risk preferences of the company and the manager, and the incentives that are provided to the manager to avoid risk. In other words, incentive systems. Producer search is when we're trying to source inputs, and these mimic the consumer search we saw before because we're shopping. We're shopping as individuals in our own search, and we're shopping as managers in search of inputs. Profit maximization under uncertainty can use probabilities again to guide us toward the right decision. If demand is uncertain, and the manager is risk neutral, then the manager will want to maximize the expected profits by producing the output where the expected marginal revenue equals the marginal cost. Here's an example. Appleway Industry produces apple juice and sells it in a competitive market. The manager must determine how much juice to make before the market price is established. Economists estimate that there's a 30% chance that the market price will be $2, and there's a 70% chance that it'll be $1. So if the firm has a cost function of C equals 200 plus 0.005 Q squared, how much juice should be produced by the company to maximize expected profits? And what are those expected profits? Using the information provided, we see that profits equals price times quantity minus 200 minus 0.005 Q2, those last 2 numbers reflecting the cost. Since the project is uncertain, the revenues and profits are also uncertain. To maximize the profit, we need to calculate the expected price and use that in our decision. The expected price is equal to 30% probability times $2 plus 70% probability times $1, leading to an expected price of $1.30. We then use that compared to 0.001 Q as the marginal cost, and we determine that Q equals 1,300 gallons. At that level of production and sales, the expected profits, plugging in the 1,300 to the formula above, the profit formula, we will get to an expected profit of $645.